Hi, Math Analysis. This is Miss Kaiser, and this is your last chapter of the year, and it's broken up into two tests. A test on 10.1 to 10.3, and a test on 10.5 to 10.7. You will get all worksheets. You don't need to use your textbook at all. You should print up the blank notes and then watch the video and fill in on the blank notes. And the keys for the notes are chunked, like the keys for all of 10.1 to 10.3 are together. Everything is pretty clear in this spreadsheet. You should also all be registered for Google Drive, and that's how you're gonna, or Google Classroom, and that's how you're gonna hand in your homework. So we're starting out with sequences and series. So a sequence is an ordered list of numbers. Okay? And so when we talk about a sequence, we'll eventually be solving problems like this. A gardener buys a plant that is 12 centimeters in height. Each week after the plant grows 10 centimeters, the plant is 12 centimeters higher at the beginning of the first week. Find the height. So the first week, it is 12 centimeters, and then it grows each week 10 centimeters. So the second week would be what? Yes, 22 centimeters. And then the next week, you add 10, so 32 centimeters. And so on. So you've got 42 centimeters and 52 centimeters. So the nth term, which we're going to be getting more into as we move on with the next couple sections. But in this case, the nth term is 10n plus 2, because 10 is how much it grows. So 10 times n, when you plug in a 1, you get 10 centimeters for a sub 1, but a sub 1 is not 10 centimeters, it's 12. So you need to add the 2 to get you your 12. Now, when you plug in a 2, and you notice when you plug in a 2, you get 20 plus 2 is 22. So a sub 2 is 22, which you can see there. You're going to get a formula in the next section of actually how to get that a sub n very easily. Terms. The function value of the sequence represented by a sub 1, a sub 2, a sub 3, and so on. So the reason why I say sub is because that's a subscript. It's a little bit below the letter. A finite sequence is a sequence whose domain consists of only the first n terms, positive integers. An infinite is a function whose domain is the set of positive integers. And so it says write the first 4 terms. So all you're going to do here is plug in a 1 to get the first term, a 2 to get the second term, a 3 to get the third term, and a 4 to get the fourth term. So I plugged in a 1 and I just did the arithmetic. I plugged in a 2 and I just did the arithmetic. So take a moment to look at that, see if you understand that. Find the third term and see if you can figure out a pattern. And you notice that you keep adding 2 each time. So you should be able to look at this and just know that the fourth term is 13. Or you plug in a 4 and use the formula. So I've listed all 4 terms above the problem. Okay, the next one, you're going to plug in a 1 in for n, and notice there's 2 places for a 1 to be plugged in. And there's the first term. Then you keep going in the same pattern. And you should notice that that negative 1 to the n power is just making you alternate from positive to negative. And in this one, I just use the formula all the way because it was harder to figure out the pattern there. And then below the problem, I have listed all the terms. So if you have any questions on any of these notes, I will provide a Zoom session sometime this week to ask questions. Great. On to the next slide. The Fibonacci sequence is a famous sequence. Well, we talk about recursive sequence. So what we just did was explicit sequences. That means you could plug in a 1 to get the first term, a 2 to get the second term, a 3 to get the third term. But a recursive sequence is when you have to know the previous terms. So a recursive sequence, each successive term depends on one or more of the terms that came before. Fibonacci sequence is a pretty famous sequence. So when they give you the formula there, a sub n equals a sub n minus 2 plus a sub n minus 1, that just means to get the third term, you add the first and second term together, and so on. And here is the Fibonacci sequence, 1, 2, 3, 5, 8, 13. So the first term is actually 1, so you can add